Hi, hello, I am from Aislyn Technology. Today we are going to do project is IOT based agriculture monitoring system and automatically control water pump. By using this project we can control the water pump automatically and whatever data means whatever connected sensors in this project, that data we can see in mobile phone, means live data we can see in Android phone by using IoT app. In this project we are using Arduino Uno. Arduino Uno we are using here microcontroller and gas sensor. By using gas sensor we can measure the gases and LES sensor. By using LES sensor we can measure the light intensity and moisture sensor. By using moisture sensor we can measure the moisture content in the soil and water pump. This water pump is used to like whenever water content is low, on that time automatically this motor will run. This motor we are connected to relay. Relay is we are using here switch and this is the temperature sensor. This is the waterproof temperature sensor. By using this temperature sensor we can measure the temperature. Now we can see how to connect to all components to the Arduino Uno. First we have to take the Arduino Uno. From Arduino Uno to breadboard we have to take the common VCC and common ground. I take it from Arduino Uno to breadboard, common VCC and common ground. And next gas sensor. Gas sensor consists of 4 pins. One is VCC and next is ground and next one is the D0 and next one is the A0. VCC to VCC, ground to ground we have to connect parallelly and we are using here analog pin, so we have to connect A0 here. Here VCC to VCC and ground to ground I am connecting parallelly and A0 of the gas sensor pin is I am connecting A0 of the Arduino Uno and LES sensor consists of 3 pins, VCC, ground and D0 pin. VCC to VCC and ground to ground and D0 pin is we are connecting digital pin of the Arduino Uno, means I am connecting second pin of the Arduino Uno. I am connecting VCC to VCC and ground to ground and the output pin is I am connecting second pin of the Arduino Uno and next one is the Moisture sensor. Moisture sensor consists of 4 pins. VC, ground and D0 and A0. VC to VCC, ground to ground, and if we are connecting digital pin means we have to connect to D0. If we are connecting A0 means we have to connect to analog pin. Now I am connecting here A0. A0 means analog pin. We should connect to Arduino analog pin only. Connecting VC to VCC and ground to ground, and output pin is I am connecting A0 of the Arduino and next one is the temperature sensor. Temperature sensor consists of 3 wires. Red wire is the VCC and black wire is the ground and yellow color wire is the output pin. We have to connect VC to VCC and ground to ground, and output pin is we have to connect to the digital pin of the Arduino. And here we have to take one resistor. We have to connect that resistor from output pin to VCC. Now we can see here I am connecting VC to VCC and ground to ground. And the output pin is I am connecting to second pin of the Arduino, third pin of the Arduino. Third pin of the Arduino. From output to VCC we have to connect one resistor. I am connecting resistor from output pin to VCC. We have to connect one resistor, and after that this is the water pump. This water pump we have to connect to relay. Why we are connecting to relay means relay is using as a switch. Whenever water content is low, on that time automatically switch is on. Switch is on means water pump will on. Switch is off condition means water pump also off condition. This relay consists of input side and output side. Input side we have to connect to the Arduino. Output side we have to connect to the water pump. Input side consists of VCC, ground and input pin. We are connecting VC to VCC and ground to ground, and the input pin is we are connecting fourth pin of the Arduino. We are connecting VC to VCC and ground to ground, and input pin is we are connecting fourth pin of the Arduino. And output side is we are connecting to the water pump, and motor pump consists of two pins, positive and negative. Positive is we have to connect to the relay. Here relay outside is consist of three holes. One is normally open, first one is the normally open, and the middle one is the common contact, and this last one is the normally closed. We have to connect to positive terminal of the water pump. We have to connect to the common connection, and next one is the one pin we have to connect to the normally closed, and this normally closed is we have to connect to the positive of the battery. I am connecting positive of the battery, and negative terminal of the water pump is we are connecting negative of the battery, and this is the node MCU. This node MCU we can use as a Wi-Fi module and microcontroller also, but here we are using here Wi-Fi module only. Why we are using this node MCU means we have to connect the antenna. For that we need Wi-Fi, so that purpose we are using Wi-Fi module. And here all sensors we are connected to the Arduino board. This Arduino board, all sensor data is transferring to the node MCU. Node MCU is connected to the Android app. For that purpose, we are connecting from Arduino Uno to node MCU. We have to sending data. So that purpose, we have to Arduino Uno is the transmitter and node MCU is the receiver. Here transmitter of the Arduino pin is we are connecting to the node MCU. This is the node MCU module. This module we are using as a Wi-Fi module and microcontroller also. But in this project we are using as a Wi-Fi module. We are seeing live data on Android app. For connecting Android app we need Wi-Fi. So that purpose only we are using node MCU. And here our sensor is connected to the Arduino Uno. From Arduino Uno to node MCU we are sending data, and this node MCU connected to the Android app. Here transmitter is the Arduino Uno and the receiver is the node MCU. Transmitter pin of the Arduino Uno is we are connecting here, receiver pin of the node MCU. Arduino Uno consists of first pin is the transmitter. First pin is we are connecting to the receiver pin of the node MCU. Now we have to dump the code. Here two codes. One code is to the Arduino Uno and another code is for the node MCU. For Arduino code only for the all sensor interfacing, and node MCU code is it is interfacing with the Android app. Here first we have to connect to the Arduino Uno to the CPU board. One side we have to connect to the Arduino Uno board and another side we have to connect to the CPU board. And for that node MCU also same thing. USB cable we have to connect to one side is for the node MCU and another side is the CPU. This is the Arduino IDE. First we have to install the Arduino IDE. After that we have to code and this is the Arduino code. For that Arduino code before downloading the code, we have to select the board and port also. For that we have to go tools. In that board we have to select to the Arduino Uno, and after that we have to set the port. uh, Again we have to go to the tools. In that port we have to select to which port, means Arduino Uno board, for CPU, which port we are connecting, we have to select that one. Here I connected COM8, so I am selecting COM8. After selecting board and port, we have to verify the code and we have to upload the code. For that we have to go to the sketch. In that sketch we have to verify or compile. We have to click on verify. If any errors there, it will show the errors, otherwise it will show the compilation is done. We can see here done compiling. After compiling, again we have to go to sketch. In that we have to upload the code. If you click on upload, automatically it will download the code. We can see here done uploading. Now completed to the Arduino board. Now we have to download the code to the Node MCU. This is the Node MCU code. For that we have to select the board and port both. For that first we have to go to the tools. In that we have to select the board. In that board we have to select the Node MCU 1.0. Here Node MCU 1.0 ESP12V module we have to select. After that we have to go again tools. In that we have to select the port. In that port Node MCU, which port we are connected to the CPU, we have to check, and after checking we have to select the port. Here I connected COM7, so I am selecting COM7. After that we have to verify, and after verifying we have to upload the code to the Node MCU. For that we have to first we have to go sketch. In that sketch we have to select the verify. If any errors is there, it will show the errors, otherwise it will show the compilation is done. After compilation we have to upload the code. We can see here done compiling. After compiling, we have to upload the code. For that, we have to go sketch. In that, we have to click on upload. See here, code is uploading. We can see here done uploading means code is downloaded to the NodeMCU board successfully. In this project, we are interfacing NodeMCU with Android app. So here we are using Android app is Blink IoT. How to install and how to log in and how to all data we can see here. We can see everything here. First, we have to go Play Store. In Play Store, we have to type Blink IoT. Blink IoT, yeah. This is the Blink IoT. We have to install Blink IoT. After installing, we have to open Blink IoT, yeah. We have to give our mail ID and password. If you don't have account means you have to sign up. Otherwise, if you have account means you have to log in. Already have account. We should give mail ID and password. After installing, we have to log in. After login, here we can see create new device. We have to click create new device. In that, it will ask the template name. We have to give the like any name we have to give. But here I am giving project name IoT based agriculture monitoring system. And we have to give continue. After that, here we can see IoT agriculture monitoring system. We have to click this one. In that, we have to add the gauges. Why gauges means here like whatever the sensors data we are sending to Android app, for each sensor we have to create separate gauge. Why gauge means by using gauge we can see the data. For that, we have to click here plus mark. Here gauge we have to select. Here so many is there, buttons, icon buttons, image buttons, slider, whatever we want we have switch, whatever we want we have to select. Here I am selecting gauge. Here we are sending 4 sensors data, so I am adding 4 gauges. 4 gauges I added. In that, here after adding we have to click each gauge. In that, we have to we have to give the virtual pin V1, V2, like that we should give. Why we have to give means whatever we given here. Suppose if we given here V0 means in code also we should give the V0. So that purpose here we have to give whatever we are giving here, that one we should add in the code. Otherwise it will not, that data is, it will not connect to the that gauge. I given here V1. After that again we should if you touch means again another one it will open. In that I am giving V2. And third one, I am giving V3. Like this, we have to install the Blink IoT app. In that, we have to create a channel. Channel means nothing but a project. In one project, we have to whatever we want, gauges and switches, buttons like this. We have to add, and how many data if you want means like. That much gauges we have to create, and we have to give names. Now we can see practically all sensor how it will work, and water pump how it will automatically control. We can see now. This is the motion sensor. This sensor we have to keep in soil. It will measure the moisture content in the soil, and this is the temperature. This is the temperature sensor. This is the waterproof temperature sensor. It will measure the temperature. And this is the gas sensor. This gas sensor, it will measure the gases. And this is the LER sensor. It will measure the light intensity. When this moisture sensor, it will measure the moisture content in the soil. Whenever below threshold value, that time automatically water pump will on. And this is the Blink IoT app. In this, first one is the moisture sensor data, and second one is the gas sensor data, and third one is the temperature sensor data, and fourth one is the LER sensor data. In this moisture content, we can see here 46. Just I am doing from here. We can see here 0. If we keep in the soil, it is showing 67. Means I given 40 here threshold value. If below 40, automatically water pump will on. We can see practically that one. I am removing this one. Now we can see practically here water is whenever we keep in soil, automatically water pump will on. And this is the temperature sensor. This temperature sensor, if you measure the temperature, it is a waterproof temperature sensor. Now we can see temperature is 24. If you put in water, normal water, the temperature sensor I keep in water, in normal water I keep it. in. Now temperature is before is 24, now temperature is 25. And here this is the moisture sensor. If we keep in water, it is increasing. See, now 13, if we keep in, it is going to 79. And like this, we can see all sensor data in mobile phone only, and automatically water pump it will control. Thank you for watching our video. Please share, like our channel.